Good morning, gentlemen. We're here at the mobile station here in the United Kingdom, and we're going to go ahead and give a demonstration. Please say their names.
Mian, Ilyas, Mehraj.
And
Sheikh.
Nice to meet you, gentlemen. And we're going to give them a demonstration because they're here representing the country of Pakistan to see if we'll be able to go ahead and assist them in their energy needs as soon as possible. So I'm going to give them an explanation of exactly everything that's going on because this is another historical moment. The first thing is right behind you, gentlemen. We'll go into that room first because this is the first part of that you need to know about. This is the biofuel room. And the biofuel room is the electricity that is created that runs all of this system right here. So we'll step into the biofuel room.
So you're generating electricity here?
Yes, in this room, in the biofuel room, correct. This is a 500 amp diesel generator that has been converted to run on biofuels. This 500 amps is more than enough power to be able to run the unit out there. We only need a total to run this system of 341 amps. So there's more amperage here than what is actually needed in that room. This system here, and when you hear when we start it up and it starts to go ahead and run and it's pulling up the power on that, you will hear the RPM level go up. Now if this was running at maximum RPM, this would use about 100 liters of fuel every single hour. That's what it would use, or 25 gallons.
This is 2.1 megawatt.
No, this is not. This is only 500 amps. That's all this is.
Voltage? What's voltage?
The voltage on this is 380 volts, which is that. That room in there is the 2.1 megawatts. So this is just the starting point for the mobile station to create the electricity and energy need to run that room in there. And this, when you hear it when it starts up, and which you'll hear the idle of this go up. And when it gets to operation speed in there, this goes back into idle mode, and then you'll hear meaning it's down to where it's only running around 1500 RPMs. That's it, instead of 1800 RPMs. And now it's down to where we're only using about 9 liters or 2.5 gallons per hour in operations of this system. And it's a brand new system, and that's what we wanted for the mobile station because we're producing power, and we've already done testing to this facility from this unit, and it works perfectly. And we have the voltage set up off of the generators at 2.1 megawatt at 440, or we can go ahead and set it at 1050, which is grid power for the UK.
Excuse me, what's the frequency? This is DC.
This both of them. This is 50-60, and that's 50-60. So they're both 50-60s.
Synchronized.
Yes, they are correct. And so this room here is just the catalyst that starts the system. Now also in this room, because in which I'll point out in here, but while you're in here, it has a complete fire suppression system in here. So that way if there's ever an issue in here for a fire and stuff, and this is its nozzle up here for the external of it, and it's all brand new gas, and it's this nozzle right up here is the one that I'm talking about. This is your external nozzle for the fire suppression system. This controller here is a temperature control system for the ventilation, so that way it keeps this room running at 15 degrees Celsius. And then the white box up on the wall right there, that is a fire system modular control. That if ever there's, because this is the only room that there's fuel in, so if there's ever a fire in this room, that will automatically sense it, and because these are thermostatic controlled, they'll turn on the fans. That will shut the fans off, because that way this fire suppression system will be able to suffocate the gas or the fire, so the gas that is being dispersed. But everything in here this is plug and play. It's all 100% self-contained. And what we're doing is the people here, we're going to be putting a 2,000 liter tank outside, so that way with that we'll be able to operate for about 500 days where we don't have to refuel this system whatsoever. Now we'll go ahead and go back into that room. Now in this room, Japheth, so we can close this door. In this room, this is the fire suppression system. This is the most modern technology that's available today at this moment. And it is activated. It's all operational and stuff. And if this starts to sound, in which a horn will go off, and then this will talk to you too. And then of course this red light up here will turn on. That's telling you to exit immediately, because the gas that's in here suffocates the air.
FM200?
No, this is the most modern gas in the world. FM200, when it goes into the atmosphere, it will take 2 to 5 years before it evaporates in the atmosphere. If this is released, this evaporates in 5 days. This is the most newest and modern technology available, is this system here. And that's what this system does here. So the fire suppression system and the nozzle's right above your head, right here. This is the nozzle that's for the distribution of the gas that comes out for this. But this is all electrical. And there can't be a fire in here. The only thing that can be done in here, as far as that goes, is that an electrical short. And if an electrical short happens, then you have disconnect, and it'll go ahead and shut the electricity side down on it. Also, in this mobile station, we have a complete monitoring system. The monitoring system, we have 9 cameras on it, and we have outside external cameras that can go ahead and we can, from my smartphone or from my computers or from security, we can move our cameras around. We can go ahead and zoom in, zoom out. We can go up, we can go down. So we can go any direction that we need to go to be able to do that. And we have 9 cameras, and we have them on the back side and on the front side. And then this is the back side of it. So we're able to monitor everything to do with the mobile station inside and out. Also, and I'll just shut the light off for a second, and you can see all the cameras have night vision, and the night vision are high density resolution. You can see all of us very crystal clearly and stuff, so it has high density resolution cameras, so we're able to see a day or night. So the system itself, and then there's security safeguards that's in here that you do not see, that's in the floor. And the floor has electrical cables that run into the floor, and if this is activated by home office or myself through the computing system, and we have our modular antenna on the roof, so we can talk back and forth. We have our cellular network that we can talk back and forth. But if we activate it, it's like a giant stun gun, so it can stun an individual inside and put them to their knees, and that way we can keep control over the mobile station. It also has monitoring system like low jack. We know where it's at all times. We know if it's being moved. We have a tilt system in it, so if it's being picked up, we know if it's being picked up. So security on the system is not an issue in any way, shape, or form for the system of this technology. We also have the computing system that monitors the electrical outflow and also the RPMs, the torque, the horsepower, and everything to do with that. We also have that available on this too. So we have every aspect that shows what's going out, what's coming in, how much fuel is being used. We know every single part of what we're doing here, but we don't supply that information, because the only thing that Marshall Energy does is we only sell electricity. And that's it. The mobile stations are never ever for sale. We maintain them, we supply the energy, we install them, and then we do the protection of them. And if we were in Pakistan, as example, we would turn around and we would have people from Pakistan, and we would train them to be able to do the service, the maintenance on it, to be able to the refuel and everything to go ahead and do with that. The security of it, we would have a security office set there for them as well, so that way they could be monitored right along with us anywhere in the world. So we would be working with people in Pakistan, but in the very beginning, our people would be doing it, and the only reason is because no one in Pakistan is trained at this present time, and that's the only reason. So we would be doing it with the people of Pakistan. Now, coming to the mobile station on this side here, and I'm going to go ahead and speak about this. This electric motor that we bought is a circulation pump motor. And I've turned around and we've changed the insides of it. This was rated at 500 horsepower, and it was rated at 1,650 foot-pounds of torque. That's what this mobile station was rated at, or this drive motor was rated at. I got it and I changed the internals of it, and now this is roughly 2,200 foot-pounds of torque, or the horsepower.
Steady torque.
Yes, steady torque. And then by doing so, the generator at max load needs 4,998 foot-pounds of torque to run at load. And in the middle here, and if you walk up here, this is an inertia magnetic coupling system. No, this is an inertia magnetic coupling system. Inside of this coupling system is technology inside of it, which creates a magnetic gravity weight. So it makes it stronger and more weight. When it gets up to its RPMs, it automatically, like a helicopter wash, it creates stagnatic energy. It does on the inside of there. And by doing so, it creates a magnetic field. That magnetic field makes this where this weighs basically about 83 pounds. It turns it around to where it weighs almost 830 pounds of actual weight. Because if you turn around and you shut it off, and I've had videos of this, and once you shut the electricity off to this, and that's another reason why it goes into idle mode, this takes over 7.5 minutes to come to a stop. No other system ever does that, because the reason being is because once you take the energy away from it, they stop within 30 seconds to a minute. Not this one. And that's because this assists in the horsepower and the torque by a factor of 12. So it increases the horsepower and torque by a factor of 12.
This coupling alone.
This coupling alone. This is a 2.1 megawatt generator. This generator has 4,000 different configurations. In other words, we can go 48 hertz, we can go 50 hertz, 52, 54, 60 hertz.
Speed.
The speed, yes, that's its
speed,
hertz cycle.
Can we change the speed?
Yes,
Because we'll change.
that will change this, yes, but it has the ability to change it itself internally because it has a computing system inside of itself. We can also change the voltage, so we can go from 240, 110, 120, we can go up to 1350, we can go to 1050, we can change the
11
voltage.
kV?
Yes, we can go ahead and go every direction that we want off of a U or the X or the Y. It does not matter on this. So the voltage of this, we can change this to whatever voltage that is needed for the area. And remember, this is generated electricity. Now, generated electricity, and I know that you gentlemen understand this, if you use generated electricity, like when I was young in America, if the lights, or too many people use the energy, the lights never went off. They just got a little bit dimmer. That's generated electricity. Transformers, meaning that it has circuit breakers on it. If you overtax it, it just shuts them off. So if we ran this into transformers and into circuit, we can go ahead and get out of this where it's 2.1, and I'm sure you understand because you sound like you're an engineer, that if you take this and you run this at an optimal temperature, and a temperature for an electrical generator is between 52 degrees, or that would be, so 52 degrees would be about 12 to 14 degrees Celsius to a maximum of about 26 degrees Celsius. And that will turn around, and where this is at 2.1, it actually will turn it to 2.9 output energy. And that output energy is available to the grid. This only takes, when this is in operation, this always holds back about 15% for standby mode in case there's an emergency or a load. Sometimes you get a branch would fall on an electrical cable. All generating systems will increase the voltage output by 300% for only about 5 to 6 seconds. And that is usually enough to destroy whatever's on the line, so that way it can continue its voltage, or give enough energy to go ahead and carry to whatever that you're sending it to, and then they shut down. They'll just shut off. They automatically do that as a safeguard. So now we'll go back over, and I'm going to start it for you, so that way you can see it in operations. Now that door will be open while I'm starting it for you, and I will tell you, it is very loud in here because of the Caterpillar system. Once the door is closed, it gets a lot softer, but once this turns up, you'll hear this, and you hear the combination of the generator. As soon as this gets to speed, that generator in there will go down to idle, and that's all it does. It stays in idle mode 24 hours a day, 7 days a week.
Excuse me, one question.
This is already connected with the...
No, we have to put our fence up. We've already done a testing and we connected to it, but we have to get the fence up because the cables that's running there, if you bump into one of them cables, there's a total of 7,000 amps between the 3 main lines. And that is enough to kill you.
Yeah.
And so for safety reasons and purposes, no, we do not have that hooked up, but it will be hooked up in the next 3 to 7 days here, where the fence will be up sometime this week, and then we'll be hooking up immediately.
We have the protections like earthfall protection and short circuit protections, or single phase failure protections.
Okay, all of those things are inside the building. Inside the building itself. Outside. It's outside. All that is in the outside building. Okay. In here is just the generating plant. That's it. And this is just for 2 megawatts.
Control system and protection system is outside.
Yes. And control systems are also there too.
Yeah.
So it does internal controls on itself.
Do you use or can you use a SCADA in it?
Well, we can if we needed to, but we don't need to.
No.
Because this is pure energy. We don't need to use that.
SCADA is sometimes once we are sitting far away, you can control the system.
Yes. Well, like I said, this system here is all self-contained to itself. Yeah. We can monitor it, and I can make changes to it if I need to, because in here they have a computing system right here. And this computing system can allow me to make changes in this right here.
Yeah.
This is where I can make my changes at, is on this computing system here. This system. I can change my changes on this right here. But it's just standard. When we do these, we set these up exactly for, let the energy output that is needed.
Yeah.
That's what we do. That's all we do. So if it needs just 440, we set it at 440. If it's 50, 60s.
voltage we use 11,000?
11 kV.
11
Grid
kV.
system.
Yeah, that's grid. Yes, correct. This can be set up to grid
And
if that's what you're doing.
6,600 also we use.
Yes.
6.6 kV.
Yeah,
6.6
in which that can be set up here too. And if it's at 50 hertz or 52, 54, it doesn't matter.
We use
This-
50.
Yeah, so that can be set up that. Here in the UK, it's 50, 60.
Same we do.
Yes.
in Pakistan.
Yeah, so that's not an issue, nor is it a problem. Because that's what this is set up.
Yeah.
The only difference is the voltage, because the facility here is ran at 440. And they do have the carrier lines right outside behind this underground that we can tap into with them.
Self-cooling.
Yes, self-cooling.
Okay.
Oh yes,
Natural.
that's what. Yes, and that's what these are too. These are exhausts just to take the heat out
Yeah.
from the generator only. And then the ventilations, they're set at 15 degrees. And if you want, Jaffa, just right above your head, right here, go ahead and turn that.
Thermostat.
Yeah, just go ahead and turn it down to 0, and you'll see they'll turn on.
Yeah.
See, they turn on. No, you're safe. You're safe. It's just ventilation, and then go ahead and turn it back to 15.
This maintains the
Yes, an ambient temperature of 15 degrees,
Temperature.
which is optimal. And now there will be another one that's coming here in about anywhere from 12 to 30 days. We're in the process, my two gentlemen that were here working and installing this with me, we have a refrigeration unit that's installed in them.
Because if
And
the
then that
outside
way-
temperature is 40 something.
yeah,
you know.
yes, now it's
But
self-contained.
self-cooling does make some kind of problems.
Self-cooling.
In our country, you know, the
Right, 50
temperature of
degree.
40
Yeah,
degrees.
it's not going to be a problem for here inside of these mobile stations because we have a Thermo King refrigeration unit. We can make the temperature minus 18 inside of it, so that's not going to be a problem. We will set the temperature for optimal running of the generator, and that will be in here, and it'll be cooled directly here. And like I said, we have little strips on the ventilation. The ventilation of this is superb. I mean, all the heat from this is taken directly out of the mobile station. And you'll be able to feel the air circulation across the pump motor too. It is astounding.
Yeah.
Okay, if you want, we'll step back a little bit. Just watch your foot there from that tie down. Now, I'm going to go ahead and I'm going to turn up and start the mobile station. And then after I get that started, and I'll close the door after it gets turned on, and then I'm going to turn the circuit breaker on.
What's the decibels noise level?
Inside, I would say truthfully, with that running, we're going to be close to anywhere from 85 to maybe 90, maybe even 103 decibels on that. Once this is closed now, this door is closed, I would say that the decibel ratings drop down to about 65 to 70. And then when that gets turned on, it stays around 65 to 75. But outside, you're lucky if you're at 10 decibels. So it's very quiet.
So people are not supposed to sit inside.
No. It's self-monitoring. The only people that will come in here is for service or for just testing on the system or readings. But we'll put the meters on the outside so that way the meters will be able to be read from the outside. That way nobody actually has to come on in. And then be able, when there is set in location, this one was built as a production prototype. And this one built as a production prototype to show you exactly what they look online. This will have 3 security systems in it. First, it'll have a magnetic lock. And the magnetic lock, you need a keypad to be able to get into it. You'll also have voice recognition and a thumbprint, which will be inside it just to be able to come through the door. And the only people that will be coming through the door is somebody to do with Marshall Energy. It doesn't matter if they're an employee from Pakistan or if they're an employee from the UK or from the Netherlands or from Germany or from Belgium or from Thailand, because I'm in 17 countries at this moment. So it does not matter where they come from, they will be able to have access because our systems will have their fingerprint, their voice, everything inside of them.
So you buy fuel
Yes.
as a basic
Yes.
source.
Yes, that's the starting, that's
Yeah,
the
so
catalyst.
how big source is required to run?
Well, we're just putting outside a total of 2,000 liters. This mobile station uses 9 liters, so you round it out at 10 liters per hour. So you have basically operational there. You do that.
Hour for 2.1
Yeah,
megawatts.
yes, you're using 10 liters for 2.1 megawatts. The new design that I have, and that's what we're building now, which will be replacing this one, is 1 liter for 24 hours. So if I have 2,000 liters, I have 2,000 days worth of operations without having to refuel, because I'm down to 1 liter for 24 hours. not 1 liter per hour. And this one is that, now in my patent, when you read my patent, you can read my US patent, and my United States patent is a A1B2 utility patent. You do not get a utility patent in the United States of America unless you prove 100% your technology works. It's illegal, and it is against the law of the United States of America to issue that patent without you proving it. And this is a serial number for it, and this is the United States patent number for it, and a date that was issued. Excuse me.
So basically, this is
the output.
development. This is something which you have created. this
Yes,
part.
oh yes, all of it.
And this is all Caterpillar.
No, that's still irrelevant. If you read my patent right here, and it has it on here, this is my US patent and stuff. It is a mobile power generation system and method. Mine is the very first method patent that was ever issued by the United States government. In essence, I've taken everybody's technology. This has a patent on it. This has a patent on it. I've improved it. That has a patent on it. That has a patent. Everything in here is patented by somebody else. But I've taken them together and created a method to create better energy output and making it cleaner and greener. And by doing so, the United States government, after 30 years, said, we can issue this patent to this gentleman. So it took me 30 years to get the patent. And it is mine. And it's the first energy patent in the United States that's ever been issued to a private individual.
Yeah.
All patents have all been issued to corporations before mine.
That's really good.
Okay. Now, this will be noisy, just so you understand. And it only takes one button. After it's running, I'll close the door so that way you can hear that start up. And in that way, you'll hear that start up. And it only takes one button to start this. So I'm going to start it right now.